really specifically to work on Tendermint Core. And I
Yeah.
say that I've always had this soft spot for consensus algorithms, which is true. Before I was working on Tendermint, I just really enjoyed reading papers about them and working with them and working on sort of various like distributed data problems. That was sort of what I was most, that was always sort of my home in the blockchain space, even before I came to Cosmos and came to Tendermint. So yeah, that's very much my background and my area of interest. As well as sort of general engineering management stuff as well. I do a lot of that for Interchain.
As far as the engineering management side of it goes, I think that building consensus protocols requires a lot of human consensus as well. And I think that the engineering management part, the longer and longer I do this, is the hardest part. And for those that don't know, Tess is fantastic at that piece of it. And I was listening to you on the Citizen Cosmos podcast a few weeks ago, and you talked quite a bit about engineering management on there. And one of the things that really struck true for me was the difference between a CTO and a VP of engineering, and kind of how you think about your role there. I really liked that point you made.
Totally. I mean, and the thing I would say is I think these roles are all what people make of them, and the titles are all kind of made up and all of that. But there are sort of some trends between the two of them, and part of the reason why I'm a VP and not a CTO at this juncture and with this team is that I really am a little bit more focused on keeping the ship sailing forward from a people and organizational and product perspective, rather than focusing purely on spiking out technical components or other things that CTOs sometimes do.
Yeah, for sure. And, I also see you in the code as well sometimes too. So
I try to get in there.
Tendermint is at a really interesting spot right now. And back in my first role at InfluxDB, when I would go to companies and try to sell them the database, sometimes you get these crusty old DBAs who would say, like, if the database hasn't been around for 10 years, like, don't even talk to me about it. And, Tendermint is kind of reaching this slightly long in the tooth point, and we're starting to have to make some relatively thoroughgoing changes to the whole system in preparation for, I think, 1.0, maybe in about a year or so. Is that accurate?
Yeah, that's the current plan. I mean, it's really hard to make these kinds of estimates, and I don't want to stand by any hard promises here. And actually, maybe
totally.
This is a good time for me to say something that I said to Jack right before we started the live stream, which was that I'm really using this conversation as an opportunity to talk super candidly about sort of like where we're at with our roadmap and processes. And so I'm going to be talking probably about some things that are not set in stone in any way, but they're the kinds of things that we're talking about on the team. So this seems like a fun opportunity to share that stuff. So sort of with that context, I would say that we are trying to ship 1.0 probably like next summer is probably when that will happen. And we really, as Jack was saying, like Tendermint Core is getting to be a bit older. And it's kind of a funny thing that it's never been a 1.0. It's never hit that 1.0 release. And I kind of had this moment, actually, I would say last summer, where I was like, oh my gosh, like this is a product that secures so much value. I mean, if you go to like the ecosystem or token page of like the Cosmos network now, you can see it's like over $100 billion in value are secured by, Cosmos technology and Tendermint Core. And to have that not have any of the stability guarantees that go along with a 1.0 release is honestly wild. Like, and so sort of working backwards from that goal of like, what does it actually mean to have a product that is secure enough, stable enough, not going to pull the rug out from under our users in any kind of way. And working backwards from that goal, we were able to put together a roadmap and a rough timeline for what a 1.0 release might look like.
I think that you also took the alpha label off of it last summer too, which was a huge moment.
I mean, I think also we were just like, we do have more confidence in this now. A lot of what we've been doing in addition to building features has been in sort of testing and reliability and sort of correctness verification of the product. And so, I don't know if it was quite last summer, but sometime in the last few months, we switched from alpha to beta, whatever that means. So,
Yeah,
um,
if you go to the Tendermint release page, every release has this screaming warning at the top in all caps with stars next to it. Warning, alpha software, and now warning, beta software. But I think that it's kind of a testament to how Tendermint started, and like the early proof of stake space. All of the researchers and people involved were very like, maybe this works, maybe it doesn't. And the only way we've been able to figure out whether or not it works is like people are actually out there deploying these systems and they do work in practice. So that's a really cool thing. So diving into a little bit more to what 1.0 means, I think that from a client perspective, it means addressing some of the more painful pieces in Tendermint, in some of the things that have worked great, but maybe we don't know really why or how well they work, and they've gotten hard to debug. And I think the first one of those for me is the P2P network. So do you want to talk a little bit about the P2P work you guys are
yeah,
doing right now?
absolutely. The peer-to-peer layer. So, I mean, I guess to zoom out a little bit, like Tendermint Core is built in this way where there's lots of kind of modules and components that all come together, much like the SDK
Yeah.
is built with sort of the same design principles in mind. And there's this sort of peer-to-peer component module that is like the oldest and kind of least updated, least touched piece of code in Tendermint Core, or at least this was the case prior to uh, uh, prior to our work on refactoring it and rewriting it. And this had two problems. So one was that it was kind of old and no one had really worked with it very much. But it was kind of threaded throughout the whole system. So, like I said, Tendermint Core is sort of designed to be built in this modular way, which should let you kind of deal with distinct problems, have a good separation of concerns, not worry that pulling out, a brick here is going to lead to a collapse of the whole system. But the peer-to-peer stuff was architected in such a way that if you touch one piece of it, you might have unexpected effects somewhere else. So obviously that's a big issue, especially if you're trying to onboard. We're really trying to grow the team right now. We're trying to increase development velocity, and having a piece of core infrastructure in your infrastructure that behaves in that way is really counterproductive. So that was sort of the first problem. The other problem was that, you said when you sort of introduced this work, I think you said it works, but we don't really know how. The problem, which was true to some extent, but the problem was it actually wasn't always working.
Yeah.
And I think sometimes having a black box mystery in your code base can be okay if it really truly is stable and you really can rely on it. And that just wasn't the case with this stuff. So the sort of biggest symptom of that was that we had a handful, not an enormous number, but like 2 or 3 security vulnerabilities come through last year, and they all were DOS vectors in the peer-to-peer layer. And so that was just, to me, again, if we're prioritizing security and stability, that's a huge flag. And so that became something that we really decided to prioritize pretty early. And the thing about the peer-to-peer work to know as well is that it's kind of it's one of those things that's interesting because it is fairly internal to the project, but at the same time, it has had these ripple effects on other projects in the ecosystem. And even Jack, I think your familiarity with like the pain points of the peer-to-peer system is emblematic of how kind of like leaky this problem was, because these kinds of internal things, you think mostly the core team should be dealing with it. And if our users, if other people in the ecosystem are looking at it and saying this is a problem, that's how it's really a problem. And so one of the interesting things about that dynamic as well is that there's been a lot of ideas from community members, a lot of requests. A lot of people have said like, oh, why don't you try using libp2p or other solutions, whether that's
Yeah, I
different.
was going to get into the libp2p thing because that has been an active conversation for quite a while. And if folks who are not super familiar with this process at Tendermint know anything about peer-to-peer layers, you've probably heard of libp2p.
Totally. So that it's been this very cool thing where we've had a lot of input and feedback from people. And the thing I would want the community to know right now is that we've really broken this peer-to-peer refactor process into like 3 phases. And the first one is just the kind of pure refactor to kind of disentangle things. And the first problem I described, where if you touch one part of the stack and something crumbles somewhere else, we're just addressing that problem first. And then, moving forward, we'll start exploring more things that could be breaking protocol changes or might impact compatibility with other Tendermint implementations, things like that. So where we are in that process actually is we're just wrapping up that first phase where we've kind of rearranged a bunch of the guts to try to make things a little bit easier to work with. And then at some point in the future, we'll start exploring, other transport protocols and things like that we may want to bring into the system.
So one thing that I do kind of want to zero in on a little bit, a big part of being an engineering manager is making like a build versus buy decision, or in the case of open source, a build versus adopt decision. libp2p is a very interesting case of this particular decision, and I believe that we've ended up deciding to rebuild a in-house peer-to-peer layer specifically for Tendermint and this use case. And I just want you to walk through that decision a little bit, because it's not always obvious how to make this decision. These are the kinds of hard engineering decisions that, if you're just starting in engineering management and you're presented with one of them, you're like, how do I think through this? So how did you, Tess, reason through this build versus buy decision on libp2p?
Yeah, that's a great question. I think I would say that the main factor there was that we weren't starting from scratch. And so we already had a pre-existing, all these pre-existing networks that are running Tendermint core. We have, there's a Rust implementation that's underway that's doing its own thing. And we sort of committed, even though it's pre 1.0, on some level we have committed to certain, protocol interfaces. And the way, like I said, the way that Tendermint core is written is very entwined with the peer-to-peer layer at the moment. And so, I think there's a lot of enthusiasm for libp2p. And I also, we have a very small team right now, given the order, or in the context of the impact and the magnitude of the project, it's a really, really small team, right? So you want to be really judicious about what you choose to build. So in all of that context, it's like libp2p sounds great. The problem with it is that it's not just a library, it's really like a framework, and it's a little bit more opinionated about how you should build applications that work with it and use it. And Tendermint core just wasn't set up to work successfully with it. And so we realized that actually integrating libp2p would be probably a similar magnitude of project as just kind of like polishing off and rewriting some parts of the internal guts ourselves. And so it kind of became like a build versus build decision in some ways versus a build versus buy decision. And so that's sort of where and especially given, the fact that we sort of have had these pre-existing interfaces that we wanted to continue to use, it really started to feel like to use libp2p at this point would kind of feel like trying to shoehorn some things together that weren't really built to go together. That doesn't mean that we won't perhaps reevaluate this in the future, especially as both Tendermint and libp2p evolve. It may be that they end up evolving in ways that are more flexible and create more basically interoperability there, I guess. And in that case, the idea of not needing to maintain our own peer-to-peer layer ourselves is really appealing. It was just not like a match right now.
No.
So that's how we made that decision.
Yeah, not feasible. Yeah, that's a great walkthrough. And I think you guys also had the advantage of being able to see the Ethereum folks working to integrate libp2p and ETH2, and also the Polkadot ecosystem is working with that, and seeing some of those challenges that they had run into, as well as some of these impedance mismatches in Tendermint, makes a lot of sense. So you were also talking about sort of how, very weirdly for a pre 1.0 product, we do have a lot of interfaces that we're looking to maintain. And that gets onto the next major piece of 1.0 on the road, which is ABCI++. So for folks that don't know, ABCI is how all applications, the Cosmos SDK and all of the other uses for Tendermint, talk to Tendermint. And as you can imagine, that's a very a very used interface. So what are the changes and additions you guys are thinking about for ABCI? And how are those going to help users?
Yeah, so ABCI++ is a proposal from the team over at Sika. And basically, it is designed to create a lot more flexibility in the way that Tendermint and the application interact with each other. So basically, it introduces new phases to the kind of back and forth between Tendermint and the application. And when I say the application, I mean like the Cosmos SDK or any other application, or I should say an application built using the Cosmos SDK, or any other kind of like blockchain application that then uses Tendermint to do, consensus and state machine
Like,
replication.
what's the Haskell framework called? And then there's the IXO thing that they built. There's a few other frameworks on top of Tendermint, and I'm having trouble with the names right now, but those are great examples. And
Totally.
yeah,
Yeah, and
just
there's also
real quick,
applications that are, oh, go ahead. Yeah.
I was going to describe ABCI real quick. So most databases, you're sort of inserting in a key value store and you're retrieving data. This is not how Tendermint works. Tendermint works, there's a function that you run at the beginning of the block, then you deliver transactions, and then there's a function that you run at the end of the block. And that's like basically what ABCI is. And this is telling Tendermint to kind of continually go and churn out these blocks. So that might be helpful context for what you're about to talk about next.
Right, totally. So I'll keep this a little bit high level, but like basically we're adding phases to that. So instead of just, sending information into the block, you can actually kind of like propose some things first and then get that, have stuff come back. And there's a lot, the reason this is so exciting is that I think there's been a lot of, as more and more people use Tendermint, and we sort of touched on frameworks and how there's Cosmos SDK, but there's also a lot of applications that use Tendermint without, one of these other frameworks as well. And so we want to provide, these projects just have increasingly specific needs. And so we wanted to provide an interface that would be flexible enough to support a really broad range of work. I think one example of something that will be enabled by ABCI++ that is like really kind of a dramatic change is that applications will actually be able to use Tendermint with a immediate execution model. So what that means is that right now, Cosmos SDK applications, currently all Tendermint applications have what we call a delayed execution model, where the application state isn't applied to the application and those changes aren't executed until after the block is confirmed. So like a block comes in with all these instructions for like how you change your state, right? And that gets confirmed and then it gets applied. And, some projects want to have an immediate execution model where you're actually applying that state like as the block is being confirmed. So your state matches your block height, whereas right now the state matches the block height -1. And this might sound very finicky or detailed, and it is, but it does make a difference for some applications. And this is the kind of thing where we were not really willing to completely switch the model for everyone, because that would also mean pulling the rug out from underneath Cosmos SDK users who don't expect things to behave in that way. And there are reasons why the delayed execution model is actually, I think, nicer and better. It's a lot easier to reason about. It's a lot easier to debug. So for people who don't need immediate execution, it's not going to be an advantage to switch to that. But something like ABCI++ does create this flexibility through these additional phases where you can kind of choose where you actually want to apply that state. And so that's an example of something that is pretty sweeping that's enabled by ABCI++, which is actually a fairly, the interface changes that are required is actually not that crazy, so I think it's a very cool thing.
Yeah, no, that is really cool. And this might be a little inside baseball, but if you go look at the staking module and a couple of other modules in the SDK, you'll see a lot of +1s in the code. And that is explicitly because of this delayed execution module. And I remember about a month and a half prior to Hub launch, we spent debugging off-by-1 errors.
Yeah. I think that I will say, I think, one downside of the delayed execution model is the off-by-1 sense. I would argue that is actually still worth it for having state that is more deterministic. When you have to do these rollbacks, potentially when you're applying state kind of on the fly, you create the situation where you really have to be able to sometimes roll those transactions back. This creates more requirements for the data store and like the storage model for the application. So there's always trade-offs. I don't want to make it sound like one is better than the other. But but yeah, this is just an example of like the kind of thing that ABCI++ will enable more control over for users and for applications.
Would you say that's a synchronous versus an asynchronous programming environment?
I think that there are some similarities between those two spectrums, but
Yeah.
I wouldn't say they're exactly the same, and maybe
Okay.
let's not get into that right now.
Cool. Too weedsy.
Can of
Sorry.
worms. Yeah.
Yeah, totally a can of worms. Another thing that's kind of related to this ABCI++ work is the
Mhm.
mempool as well. And
Yeah.
right now, folks are really familiar with the Ethereum mempool. There's been a lot of like really cool dark forest articles, and the truly dark forest is the Tendermint mempool. So, what are some
Well,
of the planned improvements there?
yeah, I mean the Tendermint mempool is not a dark forest in the same way that the Ethereum mempool is. It's a bad situation in a totally different way, which is that it's actually way too simple. So it's a simple first in, first out queue, which works great for systems that aren't under an enormous amount of load or don't uh, uh, it's a simple solution, which I think is a great place to start, and has really gotten these systems to where they are. So no complaints there. But as we're starting to see more networks scale up and see more transaction load, we really need something that's a little bit more sophisticated. And so this is something that we are starting to seriously design. It's something we've been hearing from users. It's a highly requested subject from users for a long time. Um, I said I'd be candid about where we're at with things. We don't have that design finalized at all. And it may be that we need to do something that's a little bit of a stopgap solution that gives people some prioritization capabilities before doing something that is truly, sophisticated and will solve the long-term problems. So we're still figuring out what that looks like. The reason that this is a little bit tricky is that Tendermint Core, it's the state machine replication consensus tool. It doesn't actually have a sense of what transactions look like. So it's hard to say always prioritize the best transactions, because Tendermint Core doesn't really have any sense of that. It needs to rely on the application. And that's also kind of where this ties back into ABCI. It does depend on that interface between the application, which knows what a good transaction might be and what that might look like, and then Tendermint Core, which is responsible for gossiping transactions and does need to have a sense of their priority, but doesn't really know how to introspect them and like pick the best transactions.
Yeah, this is I really understand why you guys are not don't have a spec here. There is a lot of user feedback that's required
Mm-hmm.
here, and as Tess is describing that flow, you can see messages passing between Tendermint and the application in a few different stages, and every application is going to want to handle that differently. Even
Totally.
I've talked to different Cosmos SDK based chains who kind of want different things out of this refactor, and
Mm-hmm.
it is this design process is definitely going to be a complex one. So will be interesting to see if there is a stopgap solution. We do actually have an audience question today for you, Tess.
Oh.
Hi, Tess. Thanks for sharing this. According to you, what is the most innovative way in which Tendermint consensus framework was used by any chain, SDK based or not? I would love a non-SDK example too. Yeah.
Yeah. Well, this is a hard thing to answer, because I think that you don't really want it's such a piece of infrastructure and so foundational. You actually kind of don't want people like doing anything that's like too radical and too different from each other. And so what I would say is that Tendermint has kind of like helped usher in this era of proof of stake, and was really provided a lot of innovation for chains in that way, and kind of created this whole new world in a lot of ways. But I don't know that I can single out like a single project that like has been using the consensus model in a novel way. It's a little bit like asking like what's an innovative way that someone's used a database. It's like less about the exact interactions with the database and more about like the cool stuff that people have been building with it.
Is
So does that make sense as a framing?
Yeah, totally. I guess, when I think of cool use cases, like one of the things that I've always wanted to see is like some big company dropping it in instead of a Raft cluster somewhere for a mission
Mm-hmm.
critical application.
Mm-hmm.
Like, do we have any of those yet?
I don't know that we do. And
Mm.
the truth is, I'm not sure I would even recommend that. Like
Yeah,
they just cover different bases. There's going
totally.
to be different use cases, and there will be situations where a raft cluster is going to be a better choice than running Tendermint. And most of those, basically where you can draw the line, I think, between those things is, do you want to have a public network where anyone can join it versus do you want a system that's closed? Because if you can rely on sort of the safety properties of having a closed system, then you can run something like Raft, which is simpler. It's going to be, yeah, I mean, it's just a little bit
Performant.
simpler to run. It's going to be a little bit more performant, and you don't need to worry about like the evidence and misbehavior handling properties that Tendermint brings to the table. Like that's just not going to be important to you. So I think it's as much about just choosing the right technology for the job, and also like on the Tendermint core side, I would say it's about making sure that we are the best, solution for people who do need those security guarantees, who do need to be able to support an open network. So I know that's a little bit contrary to what you just said, but that's very much the way that I personally view
No,
our role.
that's an excellent answer. And the priorities that you listed for 1.0 go to satisfy exactly that use case. And it's these
Right.
issues that we're just at the beginning of seeing on these public chains. And
Hmm.
this is what good engineering is. It's getting 6 months to a year out in front of your requirements and making sure that you've got infrastructure ready to meet them when they're there. And Tess, you guys in the Tendermint team are doing a fantastic job. So, before we wrap here, anything that you wanna talk about that we didn't cover?
I don't think so. I mean, I think that's really what's top of mind for my team right now. There's GitHub issues open for like all of those things. So if you go, I think they're even pinned to our repo at the moment. So if people want to learn more or jump into the conversation, or they think they have a particular request for a mempool prioritization or whatever, like
Yeah.
hop over into GitHub. That's where all the conversation's happening. And
Are you
yeah, thank you so
hiring?
much, Jack. Oh, we
Yeah,
are
for sure.
hiring. We are hiring. We're hiring mostly in Europe, but also in North America, or the Americas, but the
Yeah.
Americas and Europe time zones. And we're hiring for Tendermint Core. We're hiring people to work on IBC. We're hiring people to work on Gaia. So if you want to work on open source open source infrastructure for Cosmos, uh, hit me up.
So, and just to be clear, that is Rust as well as Go developers?
We are working in Go. And
Okay,
then
great.
we're working in Go. Thank you for the
You know,
clarification.
what I think that right now, as we are both learning, and by the way, we're also hiring at Sommelier. It is very hard to find folks who are from the blockchain world to come in and work on projects like this. So if you are a cloud developer who has been working on open source cloud infrastructure projects, maybe you understand how a Raft cluster works and you want to see how we build PBFT clusters in the wild. This is a great opportunity in all of this mempool work and all of this deeply technical work. If you're familiar with databases, it is going to be like exactly the same. So don't let the blockchain scare you, and come holler at Tess, and she's got some great jobs there on the Interchain.io website. So please go check that out. Tess, thank you again very much for joining me today. I really appreciate it. And before we run, I do need to thank our sponsors again. Sommelier.finance. Please go check that out. We've got a lot of exciting things coming up, and join our Telegram. And then also OmniFlix Media. Thank you again, Sisla and team, for being great partners on this podcast. And we will see you again next week. Do we have a guest yet? Let me check. Yes, we do. We have the Lazy Ledger team coming in next week to talk about Cosmos scaling. So that's really exciting. That's a project that I've heard quite a bit about, but I'm looking forward to having Mustafa and Ishmael explain it to me on the podcast. So thank you very much, and we will see you next week.
Thanks so much, Jack.